Hi guys, how are you? I hope you are fine and good today. Today we are going to see how to know the OSPF LSA types. Today our subject today it's more than configurations. It's like speak about topics. It's better. Yes, it's good to understand about the topics of LSA, OSPF LSA, because if you understand these LSA types, you can understand the OSPF at all. Because these LSA packets, they are very important to exchange the informations between areas, between routers. So I decided in this video to explain many things here. Actually, our configurations here, it's very simple. It's not too complicated, but the understanding of LSA type, it will take a time for us or from us to understand it. So here's in this video I will cover all kinds of LSA types and the information I took it from the CCIE routing and switching Cisco Press book. So I have a nice explanation for these LSAs. So here is our step today for our videos, and here is our scenario. Our scenario here, as we see here, we have 4 routers and 1 switch. This switch actually I added to make connection between router 4 and router 1. I didn't make anything here inside this switch, so I took it from here as it is, and I connected between router 1 and router 4. As we see here, let's begin from router 4. This is outside router. This router, it's not included in any OSPF areas. This router is outside. It's it contains the loopback 0. Yes, router 4 has loopback 0 9.9.9.9/24, and the fast Ethernet 00 connect to the switch 1. It takes 4.4.4.2/24. That's it. And also router 1 here, as we see here, router 1, it has fast Ethernet 2 interfaces, fast Ethernet and serial 00, and these 2 interfaces included in OSPF area 1. And also here I have router ID for router 1 as a loopback 0.1.1.1.1, but in my configuration I will specify my router ID for OSPF manually. I will add this manually for each router. And also here router 2, this is router, it's as we see here, it's area border router is ABR, and this router is ASBR. Router 1 here it's the ASBR router because it's separated from OSPF area into the another autonomous system. Yes, ABR here, router 2, it's the ABR because it's separate between just 2 OSPF areas. The same protocol, yes, but different areas. So this is the ABR, and it has the router ID here, and this router ID, it's not included in any OSPF areas, so I decided to put it manually. And by default I will add it. Yes, it's already added by interface loopback. You will see this. I will show you our configuration here, the pre-requested. So I did the pre-requested configurations here. I did the IP addresses for each serial and fast Ethernet interfaces on router 1, and also I added the router ID here, the OSPF interface loopback 0 for this IP address. And also here router 2, this serial interface included for OSPF area 1, and this serial interface 6.6.6.0 included for OSPF area 0. Router 3 here, I have attached between two areas. Yes, area 0 and area 2. Area 2, it is for loopback 2. Yes, I created loopback 2 with this IP address, and I included in area 2, and this loopback IP address loopback 1 for router 3 also I included into area 0. And also here we have router ID 3.3.3.3/24. This is the loopback 0 for router 3, but I will put it manually to be the router OSPF router ID for router 3. So now here is, as you see here is our topology here today we are going to speak about. Now here let's go here, yes, and we have here our topics today. What we are going to speak, we are going to speak about actually 6 topics, 6 tips here. The first one, we are going to configure OSPF network, yes, and we are going to configure to make router ID for each network, and we don't include it in OSPF areas. Make router 4 here to be reachable to all routers, so we need here to add the default route, and here is we need to static route. So now I want also to explain about the LSA types, type 1. The first thing I want to explain 1, 3, 4, 5, and 6. And the 5 tips I will explain about LSA type 2. And the last thing, I will explain about LSA type 7. So, there is nothing 6 here, just I added. There is a 6, but it's not included in our one. Yes, just 1, 3, 4, 5. Yes, and here is 2 and 7. So now let's start with the first step here. We are going to configure the network, OSPF network in each router. We are starting at router 1 here. Let's just to make it open the console here for router 1. Now let's see here, we have do we have anything? Show IP protocol, protocol, yes, it's clean. Show IP interface brief. Just I want to show you something here. Look at this. I have this this is the ID for router 1. It's included for loopback 0, but I want to add it manually just to make sure it will be the loopback, because we have here a higher than this. So I'm afraid maybe it will be, especially in router 3 here. Router 3, it has many IP addresses. As we see here, we have many loopback interfaces here, and we have, this is the higher one, the highest. And if I didn't add the router ID manually on OSPF, this will be the OSPF ID, router ID. So I don't want this. So I want to add each router here. I want to add it manually. So conft. Now I want to router OSPF 1 with the process number 1, and also here we have network. Network is 0. We have a network here like what? Like we have this is, yes, to include this 5.5.5.0.0.0.255 with area. Here is I want it included for area 1, and also this IP address, yes, this fast Ethernet 00 I want also to include it in our network, OSPF network, this like this, yes, and also network here 4.4.4.0.0.0.255 because slashing 24 included in area 1. So now here is I finished. So let's go to the router 2. Just open the console, double click on it. So now let me show you here. Let me just, maybe I forgot, I want to router ID here, I want you to put it manually 1.1.1.1. yes, this is very important. Yes, that's good. Let me just to show IP OSPF. I want just to, yes, here is the router ID is 1.1.1.1, no problem. That's good. Now show IP interface brief. Just I want to see. We have, yes, this is the serial 0 contact with areas 1, and this is contact for area 0, and this is the router ID, and I don't want to include it in any OSPF areas as my condition said. So now go to the conft router OSPF 1. The first thing I want to specify our router ID 2.2.2.2, just like this. Yes. Network, now I want to include this for area 1, 5.5.5.0.0.0.255 for area 1, and also network here. Look at this, we have adjacencies here. That's good, between router 1 and router 2 through serial 00. Now I want to include this IP address for area 0 here. Yes. So network 6.6.6.0.0.0 with wildcard mask over 24. Now area 0. I think here we complete. Now go to the router 3 here. Router 3 here, we have 2 areas. Now what is it? Yes, it is. Now show IP protocol. It's clean. Show IP interface brief, just to show what I want to include it here. Look at this. This is for, I want to include for area 0, and this loopback for area 0, and this is my router ID, and this loopback 2, this is for area 2. So now conft router OSPF 1. The first thing, always you should add the router ID here, 3.3.3.3 before any adjacencies. Now because I want to choose it. Now I want to add the network here, 6.6.6.0, yes, slash with card mask is equal to 255 with area 0. Now we will see the adjacency here. Yes, that's good. Now network 30.30.30.30 with wildcard mask 0.0.0.255 with area 0. This is included in area 0, and the last IP address is 100.100.100.1 0.0.0.255 included for area 2 here. So now I think we've finished here. We should see our routing table here. If we go to the router 2 and show IP route here, I want to see. Look at this. I have 100. Yes, this is the intra area because it's not inside the area of loopback 0. I have here 4.4.4.0 here. Look at this. This is OSPF included for area 1, and 30.30.30.30 it's included for area 0 on router 3. So now just I want to check if my OSPF router ID show IP OSPF. Yes, router ID is 3.3.3.3 as I did. And now let me show you here something. So if we did this, show IP OSPF neighbor, I should see the neighboring here. Look at this. I have two neighbors here, neighbors with router 1 and neighbors with router 3 without any DR and BDR. Why? Because this is point to point. Yes, because this is point to point. So I don't need, it's not necessary. It's not needed to choose the DR and BDR. So that's what I want to do. Now just check on router 1, show IP route OSPF. What we have here, yes, 1.1.1.100. This is for area 2, and this is for area 0, and this is for area 0. That's good. It's good. Now look at this. We have here is a 32. Why? Because OSPF, it deals with the loopback interfaces with class fault. So here we want to add just on router 3 here, just this is additional information for you. I want to just to conft interface loopback 1. I want to add this IP OSPF network for point-to-point. Yes, because I want to deal with classless. So now go to the router 1 now. You will see this is on 24. Look at this. It's 24. Now we will change also for 1.1.1.100.100.100.1. This includes an interface loopback 2. The same IP address here. And now go to the router 1. Show the OSPF. Now on 24 here. Why this is? Let me just check here. Show IP interface brief. Yes, loopback 2. Show run interface loopback 2. Yes, but maybe it takes a time. Just me show something here. Yes, now here is as 24, and here is in 24 as my subnet mask as I used. So we finished. Yes, we finished the configuration of OSPF network. We did our router ID manually for each one. The third one, I want to make a reachability to the router 4. So now just I want to show you here, I from router 3 here, show IP route. It is, I don't see the loopback interface. This is 9.9, so I'll try to make a ping 9.9.9.9. It's not working. Why? Because here is I need here, just I want to show you. Here is I want to use, I don't want to use any IP protocol like RIP, EGRP or OSPF. I want to use just static route. Just go to the router 4 here. Yes, double click. Okay, now show IP route. Look at this, I don't have anything here. So what I want to do here, IP route 0.0.0.0.0. This is the default route 0.0.0.0. It go out to the next hop, this 4.4.4.1 4.4.4.1. Yes, now show IP route. That's good. Now we have here. So now let's go to the router 1 just to show you something here. Show IP route. What do we have? What do we have here? We don't have anything, and also it's not still ping 9.9.9. Yes, because we have here also a static route. Yes, I'm just doing conft. I want to make a static route here like 9.9.9.0 with the mask. Yes, the destination prefix mask is 255.255.255.0 because it's over 24. Go out to the next hop 4.4.4.2. This is my next hop 4.4.4.2. yes, because this included 4.4.4.0/24. What is it? Here is router 1. Hit enter now. Now show IP route to check it. Yes, I have here static route here. Look at this. So from router 1 to router 4 I can ping to the 9.9.9.9 now. Yes, I have a ping, but just to go to the router 2, can I make a ping to there 9.9.9.9? I can't. Why? Because here, look at this, show IP route. I don't see anything. It helps the router 2 to go to the router 4. So what we are going to do here, we want to distribute this static route to the router 2 and router 3. So what we have here to do, go to the router 1 and conft router OSPF 1. We want to redistribute this static. It's easy. Redistribute, the command is redistribute here, static. Look at this. I want to use subnet here because OSPF, it deals with just to redistribute the classful. So I want just to make a subnet here. Sorry. Yes. Now I should see the external route on router 2 like this. Look at this. Before that, I don't see anything here. So I did this show IP route again. Yes, look at this. We have here external route 2, external route type 2 by default with metric 20. Yes, the administrative distance OSPF of external OSPF, it's 100 at 10. It's the same of the internal OS administrative distance also. We don't see anything any different here. This is by default. So now I can ping to the 9.9.9.9. Yes, that's good. Now go to the router 3. Show IP route. Now, yes, I have, here is a route. Yes, with external 2. So now I can ping to the 9.9.9.9. That's good now. Now, just I want to go to the router 4 just to check. Can I ping? I should ping because I have here as a default route. So now go to the, I want to ping to this 100.100.100.1. Yes, so now that's good. Now I can ping to the loopback interface of area 2 on router 3. So now we did the third step. We make router 4 reachable to all routers. Now I want to start, yes, my object here in this video to explain about the LSA types. I want to explain to the type 1, 3, 4, and 5 here, the first one. So what I want to do here to show you this, the LSA, this is link state advertisement. I want to go to the router 2, and here's, I can see show IP OSPF, here's database. If I did this command, yes, I can see all my link state advertisement. So let's start from the first one. Yes, but before that I want to just to show you here, this is the sequence number. Look at this. This is the sequence number of LSA. The sequence number is an incrementable. You should know this number is incrementable by the last octet here. So is incremented every time the LSA change. So every time LSA change, this number will be incremented by 1. So if a router received an LSA header with the later sequence number, yes, for a practical or for a particular or specific LSA, that router knows that the neighbor has more recent LSA. For example, if router 1 and if router 1 here send a router 2 LSA header for the type 1 LSA that describes the router 1 itself with sequence number maybe 0.8.0.0.0.0.4 like this maybe, or the 2. And if the router 2 database is already held that LSA, but the sequence number of router 2 it was less than this, it was 3 on router 1. Yes, if the router 1 was 3 and router 2 was 4, what does that mean? That mean then router 2, that's mean the router 1 here will would know that it needs to ask to the router 2 to send the latest copy of LSA. So this is very, very important to know. It's incrementable. So now if you go here, just I want to show you, open here, go to the router 1 and show IP OSPF database. Look at this. Yes, we have, I was just to complain like this. Look at this. We have here, look, we have here 2.2.2 is 2 and 2.2.2.2 is 2, so they are the same. So that's good. So if this number if this number of router 1, I want just to order it as my scenario here. If router 1 here if router 1 here was 1, it was 1, maybe not 2, and here is 2, that means router 1 will ask router 2 to send the LSA types again, yes, to be the equal. So this is very, very, very important to know. So now this is about the sequence number. Now go to the LSA types. Let's start with the first one of LSA type. This is the type 1. Type 1, it's like this. Look at this. Type 1 like this. If I have, here is the advertised router. This is the router generate the LSA type, yes, with the router ID, with its router ID. So here is I am in router 2, yes, and this advertised router, it's converted from router 2 from itself, and it's bring the link ID here. Look at this, it's bring also the router ID. So this, if I see the advertised router and the link router ID, they are the same. So that means this is the link type 1. Link type 1 is router link state. Yes, they are from area 0 also here. Look at this, because this is router 2 here. Just go up there like this. Yes. Go to the router 2 here. Look at this. Router 2 here. 2.2.2.2. This is the router ID of router 2. It's advertised, or it's regenerates from area 0 here. It's regenerate to the area 0. And also 3.3.3.3 is also regenerate from router 3. Yes, because it's advertised its link ID also to the router 2 inside the area 0. So link type 1, that means each router here in the same area creates and floats a type 1 LSA for itself. Yes, so router 2, it's flood the LSA type for itself, because this is, yes, it's flood for itself, 2.2.2.2 to the 2.2.2.2, and here is 3.3.3.3 to the 3.3.3.3. Do we have anything here also? Also look at this, we have also the loopback for area 0. This is the link type LSA type 1, yes, for area 1. Here is we have, this is for area 0, and here is we have for area 1. What does that mean? That means this is, look at this, this is router 2 also, because it contacts between two routers, yes, area 0 and area 1. So it has, here is advertised to itself for area 0 here, and here is its advertised LSA for, or floods the LSA type for area 1, and also here 1.1.1.1 also it includes for link type 1, because it is floods the type 1 LSA for itself. So, and this, you have to know this kind of LSA type 1 describes the router, and also its interface. So in link type 1, what we have in link type 1, LSA type 1 describe the router for its interfaces in that area, and also a list of neighboring router in that area also for area 1 or area 0 here, and also this last one, the neighboring in that area on each interface. So as we see here, the link type 1, it's created from the router itself. It describes the interfaces in that area, and also describes the neighboring router in that area for each interface. And we can distinguish the link type 1 by it is the advertised router. It will be the same of router ID, yes, and include for the area in the same area. This is for area 0, and this is for area 1. Yes, so router link here, it's mean like link type 1. So link type 1, it's flood the LSA type for itself, yes, to exchange the neighboring. So that's good. Now this is the link type 1. Now go to the link type 3. I want to show you here what is the link type 3 here. I want to just to step of link type 2, because link type 2 it needs maybe a different situation than this. I will show you how, but here I want to just to jump to the link type LSA type 3, which is summary netlink. This is, it's called in the summary netlink. What is the, yes, the link type, the LSA type 3. What does it mean? As you see here, we have ABR, and here is the ASBR, Autonomous System Boundary Router, and here is Area Border Router. The Area Border Router in the type 1, don't forward, sorry, the ABR here, don't forward the link type 1 and link type 2 LSA from one area to another. So because just link type 1 and link type 2 for the router itself in the same area. So can we do this? Router 3, ABR router advertised a type 3 into one area. Yes, it's advertised a router 3 into one area to the representative subnets described in both type of 1 and 2 LSA. So how can we explain here? Router 3 here, look at this. We have router 3, in router 2. I want to show you here, this says a kind of LSA type 3. Why? Look at this. It's easy to distinguish it. Here is, we have advertised router, which is mean the regenerate router. So router 2 here, it regenerate from the router ID 2.2.2.2. It goes to the 4.4.4.0 here. Yes, so it is the inside. So this is take this, yes, because router 4, router 2 take this network address 4.4.4.0 here. It takes to move it to the area 0, move it to the area 0 here. Look at this, because 4.4.4.4 it is in area 1, so it takes and move it to the area 0. Also here 5.5.5.0 it takes and also make it to the area 0. And also look at this, this is regenerated from router 3, so 3.3.3.3 it takes 100.100.100.100.0 from area 0, yes, to take it back. Yes, because this is outside, this is included for area 2, and he wants to take area 2 to the area 0. Yes, so link type 3 here is it takes the network addresses for different area to advertise to the area 0 or to the area which include for regenerate from this router, router 2. So router 2 here take this area 4.4.4.0 and take this area 5.5.5.0 and this area, yes, 100.100.100.0, take it and advertised or move it to the area 0. So take this to this and take this IP address to move it to the area 0 and area 2 to the area 0. So this is the function of LSA type 3. As we saw in the link type 1 just for the flooded the LSA type for router itself. It doesn't flooded the network addresses to the other areas. So the function of LSA type 3, it floods the or take the LSA type 1 and type 2 to the another area, yes, to the next area. So this is, it's called the summary because this is the summary netlink. This is the summary netlink. What does that mean? That means this is each type 3 summary LSA describes symbol vector the subnet mask and also the ABR's cost to reach that subnet. So the function of type 3, it takes also the subnet mask and the ABR's cost to advertised yes to that subnet to reach to the another area. We can see this like this. Look at this, show IP OSPF summary. I can do this summary by to show the cost summary address with, look at this, I want this is for this 4.4.4.0, maybe I can do this 4.4.4.0, sorry, 4.4.4.1. what is that? This is the summary IP OSPF summary, show IP OSPF summary. Let me see, just yes, just show IP OSPF database. Yes, here's summary. Yes, summary. Yes, like this. I can put the address 4.4.4.0. Yes, look at this. Now this is a good one. Here I have, here is 74. I have the metric here on router 2 for the, this is IP address, this is 74. How can this happen? This is, look at this, how this calculates 74. I have the cost here for this link 64, sorry, and also here I have 10, so 10 plus 64 it equal 74. So this is the cost of 74. This is the link type 1. This is the summary net link. This is the LSA type 3. It includes the metric also, and it includes also the subnet. Yes, here is, look at this. It includes also the subnet and also the metric. Yes, the ABRs to reach the metric. This is from ABR. This is router 2 here. We are in the ABR. It includes to the router to this area. So now show IP OSPF database here. What we have here also, I want just to show the summary net here. I also, look at this, I want to show the metric and the subnet for this, yes, for this area, for this IP address. So show IP OSPF database summary for 5.5.5.0. Look at this. Here is, I have the metric is 64. Yes, because it's directly attached to this. This is 64. That's good. It's the same. And this is the network mask 24. So here is the LSA type 3. This is summary net. It makes me, it creates the summary about the network mask and also the metric to the APR. This is the metric to the APR. Now go back again, and I want to see another link type 3. Sorry, yes, the type 3, LSA type 3. Here is, we have also another LSA type 3. Look at this. This is the summary net link states, but here is to the area 1. And if we go up a little bit, here is to the area 0. So in this, or for these IP addresses, takes to the area 0. Now I want also to take this loopback interface to go to the area 1, and also I want this 100.100.100.1 to go to the area 1 also. So this is, I should see another LSA type 3 like this. Here is it. Look, just to show up here, just to show you. This is very, very good to understand the concept of LSA, to understand how OSPF works. So now, summary net link here also, this is the link, the LSA type 3. Look at this. This is all IP addresses, all these network addresses, it regenerate from router 2. This is regenerated from router 2, and router 2. And it takes this 6.6.6.0, this is serial. It moves from area 0, takes to the area 1. This is takes to the area 1. Sorry. And also take 30.30.30.0 here, takes from area 0 and move it to the area 1. And also here take 100.100.100.0, yes, takes to the area 1. But look at this. Maybe you notice this IP address, it regenerates from router 2 here, but if we did here, this IP address or network, it's regenerated from router 3. Why this is regenerated from router 3 and here is regenerate from router 2? That's very, very simple. Why? Because here is I want to move it to the area 0. So router 3, it's responsible to move this IP address because this is directly attached to the area 0. So it will take this loopback or this network address to move it to the area 0. But here I want this network address to move it to the area 1. So router 2, it will be the responsible to make this, not router 3, because router 3, it's not directly connected to the router 1. Router 2 here it is the ABR, it's directly connected to the router 1. So router 2, it is the responsible to move this IP address 100.100.100.0 to move it to the area 1. That's very, very easy. Yes. So now we discussed the type 1 and type 3, and now let's go up here. What is that? Oh shit. Let me see here. What is this happen? No problem. So just like this, yes. Look at this. We discussed the LSA type 1, 3, and we are going to discuss 4 and 5. 4 and 5, they are really, actually, they are contact with each other, so I want to explain it together. Yes, I want to go to the router 2 again. So this is because this is my router 2. This is my area border router. Show IP OSPF database again. Look at this. Before I speak of router link type or LSA type, LSA type 4, I want to discuss or explain the link type or LSA type of type 5. Why? Look at this. Go to the router 2 first, to the router 1, sorry, and show IP route. What we have here? We have here this static route, and this is router 1, this is the ASBR. Router 1, this is the ASBR, and router 2, it's the ABR router. The first thing, the link type, LSA link type 5, it's responsible to take the external route from the outside autonomous system, yes, to take it to the inside, and ASBR router, it's responsible to do this. So link type 1, it's responsible for responsibility of router 1. So router 1, it used the link type 5. Yes, it used the link type 5 to take the external route. Sorry, to take the external route here. This is to take the external route to flood it into its area. This is area. So if we go there to the router 2 and look at this, it's very clear to see it's type 5 for external link state. What does that mean? Look at this. This is regenerated from router 1. So this is router 1, this is the ASBR. And it takes this network address 9.9.9.0, this is the external. It takes the external and flooded, yes, into this area. To the area what? To the area 1 just. And so router 2 will see the external route. So router 2 show IP route here, sorry. Look at this. Router 2, it see the external route by the LSA type 5. It comes from router 1. But how router 3 can see this external route? So router 2 will use the link type 4, yes, to advertise this external route which comes from the ASBR to advertise to the router 3. So we have link 5 and link 4. The 5, it's responsible for router 1, the ASBR. It takes the external route and advertised to the ABR. Then ABR used link type 4, LSA link type 4, to advertise to the other routers, or to the edge routers, or to the other routers contact with each other. So this is very important. Now I want to distinguish it here. Show IP OSPF database again. Look at this. As I said here, it's regenerated from the ASBR. It takes the external route. And also look at this. Where is the link type 4? Link type 4, here is it. Look at this. It regenerated from router 1 and takes from the ASBR. This is the router ID of the ASBR. So this is the summary ASB link. So it takes the summary from the ASB router to advertise to the another router with another area, to the next area attached to the area 1. Now I want to show you here how can we see or now know which is the ASBR and which is the ABR if we don't have our topology. So you can put this IP address, this command, show IP OSPF border routers. Look at this. I have here 1.1.1.1. This is the ASBR. Look at this. This is the ASBR. And 3.3.3.3. This is the ABR. Because 3.3.3.3 here, it contacts between area 0 and area 2. Yes. And router 1, it's separate between area OSPF area and the outside area, or outside protocol, or outside the static route. So, and also here it's internal. Look at this. This I, sorry, intra. Small I here, it's codecs for intra area. And the capital I, it's codecs for inter area route. So now if you go to the router 3 here, I want to show you something. And type the same command. Look at this. Here is it. He sees, yes, router 3. See the ASBR router. Sorry, here is the ASBR router, which is 1.1.1.1 with inter area, not intra. This is inter area because it's far away. It's contact to the ABR, and it sees, look at this, 2.2.2.2. It is the ABR router, but here is intra area, not inter area. Here is intra area. Yes, because it's directly connected with router 3. Yes, because router 2 is directly connected with router 3. So this is very good information to know. And here is, look at this. Also go to the router 3. Also I see here also the cost. This is the cost to the ASBR, because 128. What does that mean? 128. It is 164 plus 64 is 128. So this is about the LSA type 4 and 5. So now go to the explain to the LSA type 2. LSA type 2, it's kind of not like this, not point to point. It should be here the fast Ethernet. It should be here link between router 2 and router 3 to be fast Ethernet. Why? Because link type 2, it represents the transit subnet for which DR has been elected. So the link type 2, it's responsible about to DR and BDR. So type 1 and type 2 should be able to create topology graph of the network and also calculate the possible routes finally and choose the best route to reach to each other. So how can we see this? If we go to the router 2 here and in our database, so now we are going to go up here As you see here, we don't see any LSA type 2. Yes, because LSA type 2, as I said, is deal with DR and BDR. It's transit subnet for which DR has been elected. So as you see here, show IP OSPF neighbor. I don't see here anything DR or BDR because my connection between between router 2 and router 3 is point to point, and also here is point to point. So what I want to do here to activate the LSA type 2, I want just to replace this serial link with fast Ethernet. Yes, because fast Ethernet it deals with broadcasting. As you see here, sorry, just don't need this. Go to the router 2. Just I want to show interface, IP OSPF interface series 01. Look at this, we have here is point to point. So I want just to replace it by fast Ethernet. That's easy, just quickly here, as you see here. Yes, and I want to replace the IP addresses of serial interfaces to the fast Ethernet interface. So go to the router 2 here. Just I want to show IP interface brief. Just quickly think, look at this. I want this IP address to move it to the fast Ethernet 00. So I want just to delete it from interface serial 00 with no IP address. I want just to make IP go to the interface fast Ethernet 00 with IP address 5.5.5.2 255.255.255.0, no shut, and I want just go back to the serial 00 and make it shut down. Now go to the router 3. Here is it. Show IP interface brief. I want just to replace this IP address to the fast Ethernet 00. conft interface serial 00. I want just delete it from serial and make it no IP address. Sorry. What is that? No IP address, like this, and make it shut down. Go to the interface fast Ethernet 00. IP address. Which IP address? That's 6.6.6.3 666.3 255.5.0. Make it no shutdown. Now I will see the adjacencies. Just a moment. Show IP OSPF neighbor. Do I have anything here? I don't see anything until yet. So just to go back there and show IP interface brief. Just to yes. Now what is that? We have received invalid packet mismatch ID from backbone. Now first Ethernet 0 down. Must be virtual link. So why I don't need this virtual link. Just I want to delete this. Yes, now this is fast Ethernet 00. Let's just go back again. Show IP interface brief 5.5.5.2. Let me see here. What is this? Oh my goodness, what I did here. It is 6.6.6. Just let me see. Just wait a moment here. Here is it serial 00. Just we did something strange. Just I replace it in opposite side, so no problem. Not just go there. Go to the interface serial 00. This is serial 00. I want just to make no IP addresses, and I want to make IP address 6.5. Sorry, and also go to the fast Ethernet interface fast Ethernet 00 and make it no IP address. I want to start again. Just quickly go to this to the serial 00 here. I want to make this the true IP address. IP address 5.5.5.2 255.255.255.0. Now there's yes, no shut. Just to make sure interface fast Ethernet 00. Now Now this is the IP address 6.6.6.2 here, 6.6.6.6.2 for router 2. IP address 6.6.6.2, 255.255.255.0. It's overlap with what's show IP interface brief. With serial 01. What is serial 01? I deleted router 2. Yes, it still exists. Interface serial 01. No IP address, maybe the first one. Yes, and IP address here. I make it shut down. I don't want it. So go back to the fast Ethernet 00 now, and IP address 6.6.6.2, 255.255.255.0. I'll make it no shut. Now I think it's correct. Just what I want to do here, what I did here, I removed the serial link here, and I replaced the IP address of serial interfaces to the fast Ethernet interface. Just easy, but I did maybe some misunderstood about some mistake. I make this serial 00 no shut, and I replace this IP address to this, and this is incorrect. Just to be understand. Now I have the adjacencies. Now look at this, show IP OSPF neighbor. Now I should see the DR and BDR. Look at this. I see here's the DR. Yes. And here's the BDR. It should see the BDR here. Look at this. Let's me just to the router 3. Show IP OSPF. Sorry, OSPF neighbor here. And here's the BDR. Yes. That's it. But why? What do you think? I think this should be the DR, and this is the BDR. So why? Because this is the router ID is less than router ID of this, because the highest router ID it will be the DR. So what's happened here? Because I did some error configurations. What we want to do here, let me show IP OSPF neighbor again. I want just to make it clear IP OSPF process. I want just to make the process to begin again, start again. Now yes, show IP OSPF neighbor. Now shouldn't see this, and also let me see here in router 3 also clear IP OSPF process. Yes. This is now. Yes, now this is correct. Now I have this router 3, it's become the DR, and here is the BDR. Yes, because router 2, the show IP OSPF, I want to show you this is the router ID, it's less than show IP OSPF less than 3. So because router 3 it has the highest OSPF ID, it will be the DR, and router 2 it will be the BDR. So now I want to show you something here. In router 2, the LSA type 2 it will appear now. So show IP OSPF database. Look at this. What is router 2? Link type 2, it should appear here. Look at this, router 2 should appear with net. What is it? Let me see here. Yes, here is it. Look at this. What we have here, this is the LSA type 2. So what does that mean? This is a net link. Yes, it is because the link between router 2 and router 3 becomes the fast Ethernet, and this it's make the DR and BDR, it converted it from point to point into, look at this, show IP OSPF interface fast Ethernet 00. It become broadcast. So if we have a broadcast here, we will see the DR and BDR election. So go back just to the database. I want to show you here. This is the net link. Look at this. We have this advertised router. It's regenerated from router 2. Yes, because 2.2.2.2, this is the router ID of router 2, and it gets the 6.6.6.2. Look at this. Here is, I have a specific IP address. I don't see the network address like this. Here is, I see the IP address. Yes, because it takes, just go up there and open this just to be clear for you. Look at this. This is 6.6.6.2. Yes, it's regenerated from router 2. Yes, and take its IP address for the fast Ethernet 006.6.6.2 and advertise to the area 0. Yes, and advertise it to the area 0. Do we see anything here also? Let me see. We don't see, just this is the link type 2. So this is link type 2. It's present the transit subnet for which DR has been elected, because the DR is router 2. Sorry, the DR is router 3. So here is the link type 2. It brings the BDR IP address. It is the IP address of this fast Ethernet, and this is router 2 is the BDR because it has lower process ID, IP OSPF process ID. IP OSPF ID or router ID. It's lower than router 3. So this is router 2 is the BDR, and it takes its IP address of the fast Ethernet 00 here and advertised or flooded to the area 0 with netlink, with network link, or it called LSA type 2. So type 1 and type 2 should be able to create a topology graph and to see and calculate the possible routes and choose the best way. So this is maybe the process of type 1 and type 2, the responsibilities of type 1 and type 2. So let's go to the router 3. Just I want to see here something. Show IP OSPF database also. I want, if I see here, look at this. I want just to explain for you. Look at this. As you see here, we have this is the same. Also the advertised router here is the same. So this is type 1. So this is LSA type 1. And look at this. We have here is regenerated from router 2 and bring 6.6.6.2. Yes, with netlink, and this is LSA type 2. So this is LSA type 2 link state advertisement. It's responsible, type 2, it's responsible to take this IP address to advertised to the area 0 or to the area which links to. And also here we have, look at this, it's 2.2 regenerate from router 2 and take the IP address 4.4.4.0, this fast Ethernet, and 5.5.5.0, this is 5.5.5.0. Bring it or flood it to the area 0. So this is take it from router 2 and flood it pops to the area 0. But just here, as I said before, here is 100.100.100.0. It's regenerated from router 3. Why? Because it's directly connected to the router 3. So this is the business, yes, of router 3, or yes, the responsibilities of router 3 to advertise this area to the area 0. Yes, but router 2, it's responsible to take this IP address to advertise into area 1, as you see here. Yes. Also look at this. We have also here, so we talked about type 1 and type 2. So now look at this. So we talked about the type 2 here. It's regenerated from router 2 and bring 6 to 6 to 62. This is the IP address of fast Ethernet, and flooded to the area 0. So that's about the LSA type 2. Now we are going to talk about LSA type 7. Look at this. LSA type 7, it's need to make something different here, or to add another thing between router 1 and router 2. As you remembered, we have here, it's the external, yes, external address. I want to just to advertise or to flood it to the area 1, so I need the LSA type 5, yes, to take this external route to flood it into the ABR route, and ABR route will use type 5 to advertise into other areas. Now if I want to use type 7, here is it, type 5, type 7, it will replace to the type 5. What does that mean? Here is, look at this, I want to use to make the router 1 and router 2 to be an SSA, not so stubby area. So what does that mean? That means this, it will use type 7 here to advertise the external route with type 5. Here is router 1, it will use the type 5. Yes, here is, it will use the type 5. Yes, it will use, here is the type 5 to advertise to the router 2. I will show you how. But before that, I want to just to change the kind of area between router 1 and router 2 to the NSSA. So go to the router 1 first, conf t router OSPF 1. The command is area because we contact with area 1 and with NSSA, just like this, and go to the router 2, conf t router OSPF 1, and area 1 become an SSA. So now we will have a new adjacencies here. Show IP route OSPF, just show. Still, yes, here is the adjacency, new adjacencies. Now I should see the external route. It takes a time. So now show IP route. Can I see? Yes, I see 30, 100 to 100, 6.6. That's good. Now go to the router 2 again. Yes, here is it. Look at this. It changed from OE2 to the external 2. It changed to the N2. So what does that mean? N2, it's mean like OSPF NSSA external type 2, which is the same of E2. It used the default metric is 20. Yes, it's 20. It's like E2. Yes, it's like E2. So let's see here what happened when I change the NSSA with show IP OSPF database here. I should see many interesting things. Look at this. Look at this. Should I see here like this? Before I did this, look at this. Before I make the NSSA, the type 5, it's advertised from router 1 and comes from yes, it's bring this network address from external to the router 1 to the ASBR. Then look at this, then router 2 take from the ASBR, this is 1.1.1.1, to advertise the external route to this area. But when I change the type of area here between router 1 and router 2 in area 1, look at this, what will the difference we will see here. Look at this. We see here the type 7 here and type 5. So do we see type 4? Do we see type 4 here? Type 4, let's just to go back, sorry, just to show you what is the type 4. Here is a type 4. Where is the type 4? Yes. Summary ASP link, so to the area 0. So do we see this here? So summary link ASP, we don't see type 4 here. So type 4 here, it disappeared. It goes away. So why? Let me show you here. Look at this. It's now type 7. It takes the action of type 5 in the ASBR, just in the ASBR. So when I change the area, the kind of area between router 1 and router 2 to the NSSA, then the ASBR used type 7 to take the external route and to flood it to the ABR. Then ABR, look at this, ABR here, router 2.2.2, it takes directly the external route 10.10.10.0, 9.9.9.9.0. It takes directly and use type 5 to flood it or to advertise to the router 3. So go to the router 3 and show IP route here. Just I want to show you here. Look at this. Here is we see E2. We don't see N2 like in router 2. Here we see N2. Yes, because router 2 receive the external route from router 1 by L7 by type 7, but router 3, go back, router 3 receive the external route from the ABR, which is router 2, by the type 5. So type 5, it will use E2. So we will see here E2 and we will see here N2. So this is very, very, very important. And also here router 2, it takes from the external directly. Yes, takes the external directly from the router 1. So that was about the LSA, just to make a quick summary about the LSA. LSA type 1, as we see here, we noticed the advertised router is the same of link ID. So that means this is the type 1 which flooded to the router itself. And we see here the type 2, which is netlink state, which is advertised or regenerate from router 2 and advertised 6.6.6.2 to the area 0. And this is the kind of type 2. And we have here also type 3. Look at this. We have 2.2.2.2 advertised from 2.2.2.2 and take from router 2 and from router 2 and take the IP addresses here, which exist in the routing table of router 1. So it takes the IP address or the network address in the routing table and advertise to the area 0, and take this network address also in the router 3 and advertise to the area 0, because this is included to the area 2. And also here we have also link type 1, because this is the same. Look at this, 111 and 111, 222.2.2.2. So this is advertised to the area 1 in the same router area itself. And also here we have also type 3 also, because it's advertised or regenerate from router 2 to the 2.2.2 in the 3 and take it from the IP address or the network address from the IP address. Here is it, and here is it. And also the type 7 here, it's regenerated from router 1 ASBR and takes the external route and advertise to the ABR. Then ABR, yes, advertised the outside external router to the router 3. And that was everything about us. And we configured the OSPF network, and we knew how to specify the router ID for OSPF, and we make router 4 reachable to the all routers here. And we discussed the LSA type 1, 3, 4, 5, Then we discussed type 2, which is responsible for DR election, and we talked about type 7, which is responsible for NSSA because it replaced to the type 5, and with type 7 and type 5 it will use by the ABR, and type 7 it will use for the ASBR. So that was everything about the LSA. It's very, very important to know it. This is about OSPF LSA types, about everything about it. So I hope it is valuable for you, and I hope this video to be beneficial for everyone who wants to know about LSA types. So that was everything in this video, and see you in the next video, and bye bye.